Hey everyone, today we are diving into the 7 fundamental principles of software testing. And look, these aren't just some boring rules on a checklist. This is the core philosophy, really the mindset that separates the projects that succeed from the ones that just descend into chaos. Let's get right into it.
You've been there, right? You download a brand new app from a huge, well-known company, and it crashes. You have to wonder, how does that even happen with all their money and all their resources? Well, a lot of the time, it's because without a solid philosophy to guide them, a project can get messy fast. And this isn't just about avoiding a little bit of user frustration. In today's world, for so many companies, your software is your business. This quote really hits at home. Getting testing right isn't a nice to have. It's absolutely critical for survival. The stakes are incredibly high. So here's how we're going to break it all down. We've grouped these principles into 4 main ideas. First, we'll talk about the testing mindset. Then we'll get real about why it's an impossible task to test everything. From there, we'll lay out a smarter strategy to focus your efforts. And finally, we'll see why in testing, context is everything. Okay, let's kick things off with part 1, a question of mindset. Before you can even think about writing a test case or finding a bug, you've got to learn to think like a tester. It's a total shift in perspective. And this right here is the key difference. A developer's whole job is to build something amazing, and naturally, they're going to believe it works perfectly. You can't blame them. It's confirmation bias. But a tester's job is to challenge that belief. Their goal isn't to prove the software works. It's to find all the ways it breaks. It's a completely different way of looking at the world.
And that brings us right to our very first principle. This one is so important. Testing can only prove that defects are there. If a test fails, boom, you found a bug. Awesome. But, and this is the big but, if all your tests pass, it does not mean the software is perfect. It just means you haven't found any bugs yet. You can never, ever prove a negative.
Now, stick with me here because we're going to jump all the way to principle 7. It might seem weird, but it's the perfect other side of this coin, the absence of errors fallacy. Okay, imagine you do a fantastic job. You find and fix hundreds of bugs. The software is technically perfect. But what if it doesn't actually solve the user's problem? What if it's the wrong product? Well, then all that work was for nothing. This is the absolute best way to understand that fallacy. It's the difference between verification and validation. Verification asks, did we build the system right? Does it match the spec sheet? But validation asks a much deeper question. Did we build the right system? Does it actually work for the user in the real world? A bug-free system that fails validation is, well, still a failure. Okay, on to our next section. So if we know we can't prove a system is perfect, and we've always got limited time and money, we run headfirst into a giant problem. We just can't test everything. So where do we even begin? And that is our second principle. Exhaustive testing is flat out impossible. For any piece of software that's even a little bit complicated, you simply cannot test every single combination of inputs, every path the user could take. The number of possibilities just explodes. It's not just impractical, it's mathematically absurd. And if you think I'm exaggerating, just look at this number. That's about 168 quintillion. That's the number of possible ways you could configure the dream car in a case study. I mean, trying to test every single one of those would take, well, let's just say a very, very, very long time. So how on earth do you get to a number that big? Well, this table shows you. You've got 10 models, 5 engines, different wheels, colors, you name it. But the real kicker, the thing that makes it explode, is that last line. 50 different optional extras, and each one can be either on or off. That's 2 to the power of 50 combinations. That's what we call a combinatorial explosion. So, if we can't test everything, we have to be smarter about it. We have to be strategic. We need to focus our precious time and energy where it's going to have the biggest impact. And that's what this next section is all about, finding bugs efficiently. And the single smartest thing you can do, hands down, is start early. That's principle 3. The longer a bug lives in your system, the more painful and expensive it is to get rid of. Think about it. A flaw in the requirements document, that's just a quick chat and an edit. But that same flaw discovered after the product is shipped, that could mean a massive recall. The cost just skyrockets over time. Exactly. Early testing doesn't just mean running code sooner. This quote nails it. It means testing the ideas. Getting the team together to review requirements and user stories, that is testing. When you find problems here, you prevent whole categories of bugs from ever being written into the code in the first place.
Okay, so we're testing early. But where do we point our magnifying glass? Principle 4 gives us a massive clue. See, defects aren't spread out evenly through the code. They like to party together. They cluster in the most complex, most difficult parts of a system. A tiny number of modules usually holds the vast majority of the bugs. And that leads us to a really clear plan of attack: risk analysis. You have to sit down and ask, okay, what are the gnarliest parts of our system? Where would a failure be an absolute catastrophe for our users or our business? That's where you focus your energy. That's the heart of risk-based testing.
Now, let's say you've built a great suite of tests for those high-risk areas. You can't just set it and forget it. And that brings us to one of my favorites, Principle 5, the pesticide paradox. The analogy is just perfect. If you keep spraying the same pesticide on a field, eventually the bugs become immune. It's the same with your tests. If you run the exact same tests over and over, they'll eventually stop finding new bugs. You have to keep evolving, adding new tests and trying new things.
And this brings us to our final section. We've got our mindset, we've got our strategy, but none of it can be applied in a vacuum. Effective testing isn't a one-size-fits-all kind of deal. As we're about to see, context is absolutely king.
So here it is, our sixth principle. Testing is context dependent. How you test, what you test, and how deep you go all depend on the product itself. The way you test a simple mobile game is going to be wildly different from how you test online banking software or a medical device.
I mean, this comparison says it all, doesn't it? For a vacation planning app, the biggest risk is that it's maybe a little annoying to use, so you focus on usability. But for an aviation system, the software that helps fly a plane, the risk is a catastrophe. The testing there is going to be incredibly strict, incredibly formal, and dictated by international safety standards. The context just changes everything. So let's pull all 7 of these ideas together. You see, it's not just a random list of rules. It's a way of thinking. You start early because you know you can't test everything. That means you have to focus on the riskiest defect clusters, and you constantly have to change up your tests to avoid that pesticide paradox. All the while, you're remembering that you're only showing that defects exist in a process that totally depends on your context. And maybe most importantly, you're making sure you're building the right thing to begin with. And that's our look at the 7 principles. But before we go, I want to leave you with a question to take back to your own team. Looking at this list, be honest. Which of these principles do you ignore the most? Because the answer to that question might be the key to making your next project a whole lot better. Thanks for tuning in.